Welcome to College Algebra, Chapter 1, Section 3, Models and Applications, which is basically code for word problems. Sorry about that. Don't shoot the messenger. Let's have a look at some word problems. In this first one, again here you're seeing a list of steps. We saw this in the previous video, and we'll see it in future ones, so eventually I'll stop pointing it out, but if you're the kind of person who likes steps, this is great. This will be valuable to you. If it freaks you out, pay it no attention. One strategy that we can use sometimes is what I call direct translation. If I can take the depiction or the articulation of a scenario that's written in English, which is what we have here, and translate it quite directly into an equation, that's what I'm going to do. I love when I have the opportunity to do that. Let's see if we can do that here. When 80% of a number, how do you get 80% of a number? Is this going to move over or what? Come on now, play nice. There we go. 80% as a decimal is 0.80. Of is multiplication. Sorry, I'm getting in my own way over here. See? That's what that sounds like. Right, so 80% as a decimal, 0.80. Of implies multiplication. A number, which is an unknown at the moment, so I'm going to call it x, is added to the number. We're going to add it to the number. The result is, that's an equal sign, 252. So this is very much direct translation. There's the 80%, there's the of, there's the number, there's added to the number again. The result is, that's an equal sign, and there's your 252. It's not usually that easy, but if you can go rooting around in the word problem, sometimes you can pull out bits and pieces just like this. Okay, let's solve this real quick. We know how to do this from previous sections and from, when we were 10 or whatever. Let's rewrite this as, just a little bit more succinctly, as 0.8x plus, and if you'd like to think of it as 1.0x, that might be helpful, equals 252. And I'm going to combine like terms now on the left-hand side. That gives us 1.8x equals 252. And then we need to divide both sides of this equation by 1.8. And if you haven't figured it out yet, I'm not the king of arithmetic, and I don't want to steer you wrong, so I'm going to use my little 4-function calculator on my phone and do the division. 252 divided by 1.8 equals 140. So let's put a little note in here that we're dividing by 1.8, putting that in parentheses, and the result is x all alone on the left-hand side because a 1.8 under here would cancel out with a 1.8. And we said the right-hand side turns out to be 140. That wasn't so bad. Let's take a look at this next question. Things did not go quite as planned. You invested $12,000, part of it in a stock that paid 14%. Sounds pretty good so far. The rest of the money suffered a loss of 6%. If the total income from both investments was $680, how much was invested at each interest rate? This is another dual investment problem, and this is a type of problem that's very challenging for, I would say, more than 50% of algebra students. So let me show you how I like to frame this up, and if it works for you, great. And if you already have a method that you like, just keep using that one. So I've got a total investment of $12,000. Great. I've got 14%, and I've got a 6% loss. Maybe I'm going to underline loss. The total payout is $680. I want to know how much I invested at each rate. So I like to write down that I'm going to invest X dollars. I'll even put a little dollar sign on it. I'm going to invest X dollars at my first interest rate. So I'll put a little at symbol, and we'll say at 14%. Now we're going to invest the rest of our money at this other interest rate. Well, after I invest X dollars at 14%, I can figure out how much money I have left over by taking $12,000 and subtracting those X dollars from it. That's how much I have left over. Imagine you already spent $3,000 here. Wouldn't you only have $9,000 here? How'd you get the $9,000? 12,000 minus 3,000. All right, I'm going to try to consistently make this not rocket science. We're investing these dollars at negative 6% because it was a 6% loss. Now, how do you, if we knew what these dollar values were, how would you determine the amount of interest earned, say, at 14%? I would take my amount of money invested and I would multiply it by 0.14. So there's 0.14 times X. This is an amount of interest. And then I would take negative 0.06 and multiply it by this amount of money. We don't know how much it is yet because we don't know what X is yet, but that's okay. We're just framing things up. This is also, and I'm just writing interest under it. If you need to write some larger description of what these quantities are, do that. Whatever is going to be most beneficial to you when you're reviewing your notes later. So both of these are the calculation of an amount of interest. And if I take the interest from, or the gain, which is a positive number from my first investment, and I add it to the gain, which is going to be a negative number for my second investment, I will know what my total income was, or total interest earned, I've called it previously. Total interest earned, TIE, which is not an industry standard term that I'm aware of. I just made that up. All right, so interest plus interest equals total income or interest. So that's if I took this amount, which I don't really want to put parentheses around, and I added it to this amount, right? So if I add these two quantities together, I'll know what my total interest or income earned on my investments was. If only I knew what that dollar value was. And then I look at the question again, and I see that I've even circled that dollar value. It's $680. Well, what we've got now, if you look at this, is one equation that only has one variable in it. You know how to solve equations that look like this. We're going to do some distributing. We're going to combine like terms. We're going to get our variable all alone on one side of the equation, and then we're going to have an answer, which we're going to have to interpret just a little bit because this is a word problem, but otherwise this is not going to be a very taxing experience. It'd be funnier if this problem were about taxing, interest rates, and so on. Anyway, so let's distribute. We're going to keep the 0.14x. And now we're adding a negative 0.06 times 12,000, which is 72 with 1 0 after it, but it's negative. So that's negative 720. I can already tell I'm going to need a calculator again. I know most of you are feeling me on that. Also, we've got negative 0.06 times negative x. So that turns actually into a positive 0. Come on, pen. My pen's going to become my nemesis. One of these days, I'm going to have to get a new pen. 0.06x, and that's equal to the value on the right-hand side, which is still 680. Let's combine like terms on the left-hand side. CLT. The 0.14x's and the 0.06x's, add those together, and you've got 0.20x minus the 720 still on the left-hand side equals the 680 on the right-hand side. Let's add the 720 to both sides in order to get our x value all alone. So we can write that as 0.2. You don't have to write the 0 after the 2 if you don't want to. X is equal to 1400. And then if we divide both sides by 0.2, we'll get an x value of, oh, I went right off the screen, sorry. I'm writing on an iPad, which is twice as tall as the available real estate that we have on our screen here. So sometimes I'm going to go right off the screen. So we need to divide both sides by 0.2. If we had multiplied both sides by 10 first, then we'd have 2x equals 14,000, and we could divide both sides by 2, and we'd have x equals 7,000. Or you can use a 4-function calculator, or probably an abacus, really. This is pretty easy arithmetic. We've got an x value of 7,000. 7,000 what's? $7,000. The question was how much was invested at each rate. You can see that right at the top of the screen there. And I don't remember. $7,000 is invested. Was it invested at the, what was it, a 14% gain or at the 16% loss? And as it turns out, I'm actually hiding it. I was going to try to move me. There we go. We wrote a little note up here. Look, I'm looking right at it. See that right there? It says that we invested X dollars at 14%. So that is, if you're choosing from a multiple choice, if you're in a multiple choice situation, you want to make sure that you're choosing the multiple choice option that says 7,000 was invested at the 14% interest. That's going to be option D. Option A is going to have 7,000 invested at the wrong interest rate, but you might see that $7,000 number, think that it's the right one, and choose that. So be careful all the way through this process. I'm just going to go down here and write 7,000 at 14%. That's part of my answer, and then we could do the 12,000 minus 7,000 to get 5,000 at the 6% loss. I'm going to leave you to write that in on your own, and I'm going to get set up for the next problem. For the next problem, we might need one of these equations. I loved geometry. I don't know if you loved geometry, but knowing these equations and I guess I memorized them, I suppose, but knowing that I had those in my arsenal made me feel very empowered in a geometry class. Which makes sense because that would make me a math nerd, and here I am a math professor. But I even remember that far back really enjoying geometry. Algebra 2, pre-calc, calc 1, calc 2, calc 3, diffie-q, that's 6. So after geometry I took 23 other math classes, including high school, college level, and graduate school. I need to get a life. The length of a rectangular pool is 6 meters less than, oh, I hate it already, right? That's what you're thinking. You've just read that, you hate this problem. I don't blame you. The length of a, let's see if we can do direct translation. Maybe that'll work. Let's see. The length of a pool, I'll call it capital L, very creative, of a rectangular pool is, there's the equal sign, 6 meters less than, be careful. This is very strange. We run into it every once in a while, and you have to be really careful when it's 6 meters less than. Because to decrease something by 6, you have to know what it is that you're starting with first. So there's the decreasing by 6. And what is it that's being decreased by 6? Twice the width. All right, so L equals 2W minus 6. If the pool's perimeter which is calculated by taking twice the length and adding it to twice the width, in the case of a rectangle anyway, the problem tells us that the perimeter is, see the is the equal sign, 126. What are its dimensions? In other words, what's the length and the width? How am I supposed to figure that out? Well, one is knowing that you should be taking the given information that's in English and converting it to some kind of an equation. I've also chosen appropriate variables, which I recommend that you do also. You could use x's and y's, but you're liable to swap them around and end up answering a question wrong. The strategy that I'm going to use, or the technique that I'm going to employ here, is called substitution. I'm going to take this L that's right here, and I'm going to replace it with something of equal value. If only I knew what L equaled. Oh yeah, it equals 2W minus 6. So we're going to take that and put it in here in place of this L. So by substitution, comma or colon, 2 times our new L value of 2W minus 6 plus 2W is 126. So if you had a highlighter or multiple colored pens or something like that, look, this 2 is this 2. The L is being replaced by all of this stuff. Here's this 2 right here. Here's this W. The equals, the 126, right? So all those things match up. The only thing that's changing is that we're swapping out things that are of equal value, replacing the L with the 2W minus 6. Now what you've got is another equation that looks like all the rest of the stuff that we've been working on so far this semester. Distribute, combine like terms, isolate the variable, right? You should be happy when you get to this point in the process. Starting these problems is difficult. That's what you need to be paying attention to. That's what you need to be practicing. Once you get to here, if I was practicing this, matter of fact, I'm tempted to not even finish solving this for you. But I want you to have final answers, so I'm going to. But really, you don't need me to keep doing this, right? So when you're prepping for an exam, if you get to this point in the process, and maybe you have a solution process to compare it to, if this line in your work is correct, and you know how to do it from here, don't spend your time multiplying and adding and subtracting, okay? Better that you go and look at another type of problem. I'm going to distribute, which gives me 4W minus 12 plus 2W equals 126. Combine like terms on the left-hand side gives me 6W minus 12 equals the 126. We'll add 12 to both sides as we isolate the variable. Divide both sides by 6 to totally isolate the W. And W is 23. And thankfully I chose good variable names, so I know that that's the width. And then I can take the width and plug it into that L equals 2W minus 6 equation in the top left and solve for L. Again, I'll leave you to do that. Solving a formula for one of its variables. This is an exercise that has some value mathematically. Surely it has a value. A very common equation that you'll work with in a problem of this style is the Fahrenheit-Celsius equation. There's an equation that says capital F equals, and then there are some calculations involving Celsius. So if somebody tells you they live up north and in Canada maybe, and they tell you that the temperature is 12 degrees and you live in the United States, you have no idea what that means. So you need a conversion equation. Well, not only do you need a conversion equation to convert their Celsius temperature to Fahrenheit, but when you tell them later in the year that it's 84 degrees, well, that doesn't mean anything to them, right? They need to take your Fahrenheit temperature and convert it to Celsius. So you can do a manipulation on that equation, and instead of it saying F equals, you can modify it and solve it for C, so that it says C equals. That would actually be a good exercise for you to go and do. Go and look up the Fahrenheit to Celsius conversion equation and try to solve it for the other variable, and then look up the Celsius to Fahrenheit conversion instead of Fahrenheit to Celsius, and see if you got the right answer. In this problem, I'm going to solve for B. This is an area equation, 1/2 the height times the sum of the bases. What's really happening here is we've got 1/2 the sum of the bases, which is the average of the bases, A and B. So this is actually the formula to find the area of a trapezoid. I loved geometry so much that I even remember that today. In order to solve this for B, just like solving for X or solving for W like we did up here, the goal is to get that variable all alone on one side of the equation. So is it possible that we could leave this lowercase b right where it is and just move everything else over to the left-hand side of the equation? Yeah, I think we can. Let's give that a shot. I'm going to start moving the stuff that's already farthest away from the b, which would be the 1/2. How do we make that 1/2 disappear from the right-hand side of the equation? I'm going to multiply both sides of the equation by 2. So actually, let me rewrite the equation. A equals 1/2 h times the sum of the bases. That's the top and the bottom of the trapezoid. And then I'm going to multiply both sides of my equation by 2. That gives me 2a equals, right, 2 times 1/2. Those are going to cancel out and turn into a 1, leaving us just with the h times the a plus b. Now you might be looking at this and thinking a couple of things. One is, how does he read his own writing? His handwriting's terrible. I'm telling you, with a digital pen, when you're writing on a tablet, especially this particular digital pen, it's so slippery. I mean, my handwriting's not great, but way better on pencil and paper. The other thing you might be thinking is, maybe I should distribute next. Don't distribute. Remember, the goal here is to get stuff away from the b. So why would you want to distribute that h in and get it even closer to the b? Let's just get rid of the h from the right-hand side of the equation. We can do that by dividing both sides of the equation by h, which would give us 2a over h equals just the a plus b now. The h canceled from the right-hand side of the equation when we divided by h. All right, this is easy now. All I have to do is subtract a, and I'm going to have my final answer. I've got 2 capital A over h minus lowercase a equals b. And if I'm in a multiple choice situation, I'm stoked because I'm going to be able to look down at my options and identify this as a right answer, and I'm out of here. And you look down at your multiple choice options and it's not there. And it's not there because every once in a while, especially in a multiple choice situation, there's these like couple of additional steps to like manipulate it or make an equation look a little bit different or something that you would never do, and you don't think there's any value in doing that, but the question or the exam demands it. And the thing that we're going to do to this equation, I've run out of real estate vertically, so I'm just going to work my way across the page to the right. We need to set this up so that there's a common denominator. So what I'm going to do is keep my first term the same, that's the 2a over h, minus, and I'm going to write this lowercase a as an a over 1, and then I'm going to multiply it by h over h. I'm allowed to multiply by h over h because h over h is equal to 1. So what I'm really multiplying by here is 1. And what happens when you multiply? Oh, that's what I did. Sorry. I went to hit the back button and my pinky finger hit the back to top or something. So I'll try to not do that again. What happens when you multiply by 1? Nothing. That's why we're allowed to do it. You can multiply by 1 and you can add 0 all day long. Nothing's going to change. Except it's going to change a little bit what it looks like. Let me put the equals b in here. And now what we have is 2 capital A over h minus lowercase a times h over h equals b. On the left-hand side of the equation, we now have a common denominator. So we can sort of do the subtraction. I'm going to come vertically down my page a little bit to this next arrow, and if my numerators here said 5 and 3, then I would actually do the 5 minus 3. The 2 and the capital A would represent the 5, and the 3 would be this lowercase a times an h, and it would all be over our common denominator, lowercase h. As it turns out, this is supposedly the most compact way of writing the solution. It's the tidiest, maybe, because it's all in one fraction. Irritating to have to go through those last couple of steps, but a good reminder of how to create a common denominator and what you might have not thought of before, which is the technique of creating a common denominator involves this wonderful trick, which comes up very frequently, multiplication by 1. I hope that is helpful to you, and I look forward to seeing you in 1.4.